Hello everyone, welcome to this video. Today I will describe about the basic principle of temperature transmitter. Please stay with us along this video for your best understanding. This is the figure of temperature transmitter. First of all, we need to familiarize with the components. This is the bulb which is situated inside the tank. This is capillary tube. This is Bourdon tube. This is connecting link. This is flapper. This is nozzle. This is restrictor. And here is bellows. This bellows is known as negative feedback bellows. Here is the output signal going to the controller. The input signal into the nozzle is 20 psi, but the output signal is 3 to 15 psi. This bulb is filled with gas or liquid. That means inert gas or liquid is inside the bulb. What type of inert gas? We can use nitrogen or helium. But if we use gas, then the system response will be slow. So that's why we need to use liquid. So what type of liquid we can use? We can use mercury, we can use alcohol or ether. Here most of the time mercury is used. The main principle is thermal expansion of gas or liquid inside the bulb and capillary tube. Thermal expansion of gas or liquid inside the bulb and capillary tube produces a 3 to 15 psi output signal. 3 to 15 psi output signal proportional to the measured temperature. Proportional to the measured temperature. It is functionally similar to proportional controller. That means this bulb is situated inside the tank. Whenever the liquid temperature of the tank increases, the mercury volume inside the bulb is also expanded. Due to the expansion of the volume of mercury, it causes rise in pressure. Due to rise in pressure, at the end of this Bourdon tube is expanded. As we know, this liquid is filled with this line, this bulb, this capillary tube, and also connected to the Bourdon tube. That means whenever increase in pressure, then the Bourdon tube end can be expanded. This point can be expanded, and which is connected with the flapper. Whenever increase in temperature, then flapper come closer to this nozzle. As flapper come closer to this nozzle, this back pressure of this nozzle is increased. Back pressure of this nozzle is increased, and according to this, the output signal will come to this feedback bellows and causes the flapper in its equilibrium condition. Again I am telling, when this temperature is increases of the tank, then expanded Bourdon tube end causes the movement of this flapper towards the nozzle. That means the gap between nozzle and flapper decreases, and the back pressure inside this nozzle increases, and which causes this pressure come to this and causes the feedback bellows to move the paper in the new equilibrium condition. That's why it is known as negative feedback bellows. And the output signal is 3 to 15 psi going to the controller. This is the main basic principle of this system. Here the approximate restrictor is this is restrictor 0.2 mm bore, here 0.2 mm bore, and nozzle 0.75 mm bore. This nozzle 0.75 mm bore, and this paper travel at nozzle. This paper travel at nozzle is 0.05 millimeter. The main advantage of this system is this temperature transmitter. This is intrinsically safe and do not require any electrical power. But the disadvantage is whenever we are using liquid mercury, this disadvantage is the capillary tube need to be as short as possible, because it need to be protected from mechanical damage. That means capillary tube must be as short as possible. And if we use gas, we know that the system response will be very slow. This is the main basic principle of this temperature transmitter, which can be used in various purposes of the control system. So I hope all of you understand. Thank you for watching this video.